All right, so we've made it to one of our final sections of Chapter 9 on solving. We've solved quadratic equations in a number of different ways, and our last method is called the quadratic formula. So our essential question today is how and when do we solve quadratic equations with the quadratic formula? All right. So we have talked about our different methods. At the beginning of our solving discussion, we talked about solving by graphing. And as long as you have an equation that you can graph or software that you can graph with, you can always use this method. And we talked about how the roots or the x-intercepts are essentially what we're trying to solve for. We set the equation equal to 0 and then solving for those x-intercepts. And usually we can see those on the graph. And so we are graphing our parabola here, and we're looking for these two places, and those are our solutions. So maybe x equals 1 and x equals 3 or something like that. So we can use Desmos, our graphing calculator, graph the parabola, and look at what those x-intercepts might be. The other method, or our second method, is solving by isolating the x, and that's where we're going to use our square root property, and that's essentially our SAD-MEP steps, our reverse order of operations from PEMDAS. When we solve linear equations, we use that. We can use that when we're solving quadratic equations, but it needs to be in a certain form. It either needs to be in vertex form, where there's just one x term that we see, so maybe something like y equals x minus 3 squared plus 4. And then we'd go about, and actually if we're solving this, maybe we have a number over on the other side of the equation. Let's say that's like 8. And so we would subtract 4 from each side, and then take the square root, and then add 3. We have used that method a number of times, so that's using that square root property. But it really needs to be in vertex form, or if we just see one x value in the quadratic equation, then we can use that particular method. Okay, solving by factoring, and when we solve with factoring, we're actually using the zero product property. So remember, that's when we take our general form equation and change it into factored form. So maybe it's like x minus 3 times x plus 5 equals 0. And then we would say, okay, well, what makes this equal to 0? What makes x minus 3 equal to 0? Positive 3 would be our solution. What makes x plus 5 equals 0? X equals negative 5 would be our solution. So that's, we can get it into factored form. That's a very quick method for getting a solution, because you just solve for what makes each one of those factors, each one of those parentheses equal 0. The last couple days, we have been using another method called completing the square. So completing the square, usually we use that method when our equation is in general form or standard form, and the a value is 1. So, say we have something like x squared plus 3x plus 5 equals 0. Okay, so if we're trying to factor this, let's see, we can't quite factor it. So we can't get it into factored form. In other words, what multiplies to 5 adds to 3. No whole numbers do that. So we then subtracted 5 over to the other side of the equation. So we'd have x squared plus 3x equals negative 5. And then we would take half of that b term, square it, get it into a perfect square form, and then solve using the square root property. Okay, so we've been working on that method over the last couple days, and I'm just kind of quickly giving you an idea of each one of these. I realize maybe that doesn't summarize it as completely as it could, but I just wanted to at least touch on what each one of these methods had us do. So our last strategy is going to be related to, okay, well, what happens when you have an equation that's in general form, but that a value is bigger than 1, so it's 2 in this case. We can't really factor out that 2. Really the only method left that the only method of the methods that we talked about is we could graph it. So we could graph it. Since the a value is bigger than 1, we don't have an a really in factored form. Completing the square is a little bit harder. We can't really do that when we have an a value that's bigger than 1. So zero product property doesn't work. It's got more than one x value, so square root property doesn't quite work there. We could graph it though. You could go in y equals 2x squared plus 7x minus 20 and see what the x-intercepts would be. So that is a strategy that you can have. But there's also an algebraic strategy that we could use, and that's the last thing that we are talking about. And once again, we're calling that the quadratic formula. So this will work when the equations are in the standard form. Y equals ax squared plus bx plus c. Will work when it's in that form, and it's also going to work when the a value is something other than 1, which makes it a little bit more challenging to do with the other algebraic methods, right? But you could graph it, and actually this formula does come from completing the square. It's kind of evaluated. It's derived, I think would be the better way of saying that, is derived from completing the square. And that's a process that I've gone through once or twice and filled up my whiteboard with why this works, with showing how it came from completing the square. But for now, you'll just have to take our word for it. All right, so we need the equation in this form, though. Ax squared plus bx plus c equals 0. And so if our equation is not in that form, kind of like with completing the square, or actually more like, writing and talking sometimes isn't the best. The zero product property, I guess, is what it would be the better reference here. We need the value on the other side of the equation to be 0. We need it set equal to 0 for the zero product property to work, and we need that to be true for the quadratic equation as well. So if you subtract 5 from both sides of the equation here, you get 2x squared minus x minus 15 equals 0. All right, so now remember our a, b, and c values that we've been talking about the last few weeks here. So our a value is 2. Our b value is -1. Just remember that minus sign in front of that x means the b value is -1. And then the c value is -15. Okay, we're going to use each one of those values here within the quadratic formula. What is the quadratic formula? This guy right here. Holy smokes, you're saying that does not look fun. Actually, to me, it looks like a lot of fun, but maybe some of you guys, not so much. But this is going to work. As long as we do the math correctly, this is going to work. It's already solved for x, so really this is just a big PEMDAS problem is all it is. You plug the numbers in and use PEMDAS, we should be able to get it. Okay, so the quadratic formula is x equals -b, the opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. And remember that plus or minus is there because remember, when you take a square root, there's a positive and there's a negative result. Now, I also like to set this to music, a song, and the song goes a little something like this. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. You might recognize that song from your childhood with Pop Goes the Weasel. Well, you can now set Pop Goes the Weasel to the quadratic formula. There are other songs that you may be able to find on YouTube that we may be looking at a little bit later as well to memorize this formula. Once you have that memorized, it's really hard to unmemorize it.